Welcome! In this video, we shall learn the line integral. We shall first give a review on single integral. Then we shall introduce the line integral by describing how to formulate it and interpreting its meaning. In the past, we have learned how to compute a single integral. For example, if we are given the function y equals to f of x, then we can compute the area under this curve with x starting from A and ending at B by using this formula to integrate f of x with respect to x from x equals to A to x equals to B. Let's imagine that you would like to buy some slices of fish for dinner. The portion near the head is more bony and cheaper, whereas the portion here is more delicious and expensive. The price of the fish per inch is given and is a function in terms of its location. When the fish lies on the x-axis, the total price that you need to pay to buy the portion from x equals to A to x equals to B can be formulated by this single integral. And this value is also equal to the filled area in light blue. Now, instead of having a fish lying along the x-axis, this time a fish lies straight with this orientation on the chopping board in xy plane. Is there any similar tool in math for computing the total price of the fish? Let us try to formulate this with the same reasoning as before. If we denote by f of xy the function representing the price of the fish per inch, then we are actually trying to compute the total area of this surface in light blue. And this area represents the total price that we need to pay for the fish. In other words, we would like to compute a line integral which can be expressed as follows. Here, ds represents the width of the tiny line segments along the fish. And c is the path that describes how the fish is oriented. In our case, the fish is lying straight on the chopping board with its head located at point A and tail at point B, with coordinates 6, 3, and 25, 12.5 respectively. This is a possible parametric equation for path C. Indeed, if t proceeds from 6 to 25, we can generate all the points from point A along path C to point B. On the other hand, if we examine ds more closely, we can see that ds equals to the square root of dx squared plus dy squared by Pythagoras theorem. We can rewrite it so that ds is now expressed in terms of the derivatives of both x and y with respect to t. As a result, the line integral, which gives the area and hence the total price, can be computed by this formula. For example, suppose f of xy equals to 1/15 of x times y. By following the deduction, this line integral gives the value 192. Thus, imagine that the chef adds up slices of fish from the head to the tail, that is from point A to point B, then you need to pay the chef $192 to buy the fish. Oh, wait! In single integral, we know that if A and B are interchanged, the value will have opposite sign. Do you think that if you ask the chef to add up slices of fish from the tail to the head instead, then instead of paying the chef $192 to buy the fish, you earn $192 from buying the fish? Let's try to figure out the situation if we progressively add up slices of fish from the tail to the head instead. Let's denote by -c the path in this situation. The following is a possible parametric equation for negative c. Indeed, if t still proceeds from 6 to 25, we are able to generate all the points from point B along this path to point A. The same as before, we can express ds in terms of the derivatives of both x and y with respect to t. As a result, the line integral, which gives the area and hence the total price, can be computed by this formula. We have the same function f of xy as before. This line integral gives the value 192, which is the same as in the first scenario. Thus, imagine that the chef adds up slices of fish from the tail to the head, that is, from point B to point A. Then you should still pay the chef $192 to buy the fish. We can see that the total price of the fish is the same no matter whether the chef adds up slices of fish from the head to the tail or vice versa. If we consider having a fish that lies along the x-axis, then treating this as a special case of the line integral, we'll have the formula as shown here for obtaining the area, hence the total price of the slices of fish from the head to the tail. And the formula as shown here for obtaining the area, hence the total price of the slices of fish from the tail to the head. You can see that the two values obtained are the same because in both cases the change in t are both positive. Please don't get confused with the property in the single integral that if a and b are interchanged, then the value has an opposite sign, because the change in x there becomes negative. Last of all, the following presents the formulas for computing the line integral with a more general orientation for the path. If we compute the line integral with either path c or path negative c with the given formulas, the values of both line integrals are the same. This comes to the end of the video. Thank you very much.